Section 7.7, complex numbers. So when we're working with complex numbers, that means we have imaginary units inside of it. So the imaginary unit, written I, is the number whose square is -1. So basically, I squared equals -1, and I equals the square root of -1. So anytime that we see -1, that's I, and anytime we see I squared, we substitute that to -1. Example 1, write using I notation. So the long way is taking out the -1, then switching it to I, and so on, but we're just going to do it the short way. So when there's a negative, you automatically put an I, and what's the square root of 25? 5. So for 32, doesn't have a perfect square, so that's I times 2 times 16, so that's 4I times the square root of 2. So this negative just means bring it back over, and the square root of 121 is 11, and since there's a negative on the inside, we make it I. Multiply or divide. So before you multiply or divide, you need to take out I first and then simplify. So here, we're going to take out the I, so we're left with square root of 3, and take out the I, we're left with square root of 5. So we have I times I is I squared, 3 times 5 is 15. We know I squared is -1, so we have negative square root of 15. Alright, again, we need to take the I out first, so we have I times the square root of 125 over the square root of 5. We can cancel out 5 and 125 because they have 5 in common. So we're actually left with the square root of 25. So the square root of 25 is 5, and then we still have that I left over. Alright, standard form of complex numbers. A complex number is a number that can be written in the form a plus bi, where a and b are real numbers. So we're going to add or subtract these complex numbers. It has to be answered in standard form, so you need an a and you need a bi. If something's missing, you add in a 0 or a 0i. So we have 4 plus 3 is 7, and then 6i and -2i is 4i. Next, we have this negative, so we need to distribute it. So we have 8 plus 2i minus 4i. So we have 8 minus 2i. Now I'm going to show you one I don't have in here that happens when something cancels out. So we have this negative, we need to distribute it. So we have 3 plus 2i minus 8 minus 2i. So we have 3 and -8 is -5, and then the i's cancel out. You see that, how they cancel? But that's not standard form, so we need to put in a 0i. So if anything's missing, you just put it in as a 0. Alright, multiplying complex numbers. So numbers with numbers, i's with i's. So we have 8 times 7, which is 56. And then I times I is I squared. But we know I squared is -1, so we have -56. And it needs to be in standard form, so 0i. Alright, next we're going to distribute the 5i. So we have 20i minus 7, oh excuse me, forgot to multiply that. 7 times 5 is 35, and then I times I is I squared. So we have 20i minus 35 times -1. So now we have 20i plus 35, but that's not standard form. We need to do 35 plus 20i. The I needs to come second. Alright, next we need to FOIL. So we're going to FOIL. We have 6 times 7 is 42. 6 times 4i is 24i. Negative 3i and 7 is negative 21i, and negative 3i and 4i is negative 12i squared. So we're going to combine like terms. So we have 42 plus 3i minus 12 times negative 1. So we have 42 plus 3i plus 12. Combine like terms. We get 54 plus 3i. Now, dividing complex numbers, since it's irrational to have I or square roots in the bottom, we're going to do the same thing as if it was square root. So we're going to multiply by the conjugate. So that's 4 plus 3i and 4 plus 3i. And how you do it is the same way. So the bottom, you just square everything. 4 squared is 16. Put a minus, 3 squared is 9, and I squared is I squared. So now we have to FOIL the top. So we FOIL our top. We do 6 times 4 is 24. 6 times 3i is 18i. 2i and 4 is 8i. And 2i and 3i is 6i squared. We're going to combine like terms and change the I squares. So we have 24 plus 36i plus 6 times negative 1. So we have now 16 minus 9 times negative 1. Combine like terms and multiply the negative 1s out. So we have 24 plus 26i minus 6 over 16 plus 9. Keep going. So we have 24 minus 6, 18. So we have 18 plus 26i over 25. And our final answer, you need to write it separately. So that would be 18 over 25 plus 26 over 25i. The I goes on the outside. And then you need to always see if you can reduce each of the fractions. And in this case, we can't. So it's our final answer. So if we have a binomial, you multiply by the conjugate, just like with radicals. But if you have a monomial, you multiply it by itself. So we have 30i over 36i squared. So we have 30i over 36 times negative 1. 30i over negative 36. We can simplify the 30 and the 36. So we have 5i over negative 6, but that's not in standard form, so it needs to be 0 minus 5 over 6i.